All right, today in class we talked about scatter plots and the correlation coefficient. So first of all, we're going to describe the correlation of a scatter plot, construct one, and then also find the correlation coefficient of one using a graphing calculator. So as a review, this is more for our next assignment than it is for today, but that's okay that we review it. This says write the equation of the line that passes through the given points. To be able to do this, you need two things to write an equation. You need a point and you also need a slope. So we're missing slope. To find slope, we take y1 minus y2, so here we'll use 5 minus 7 over x1 minus x2, simplify it, negative 2 or negative 4, which then is 1/2. Once you have the slope, we're going to choose one of the points and use what is called point slope. Hopefully you will recall this. So I'm going to replace the y1. I'm going to choose to use the first point, but you don't have to. So y minus y1, y minus 5 equals m, which is 1/2, and x minus x1, 2. And then from here you have two steps to distribute first that slope to both pieces. So 1/2 x minus half of 2 is 1. Add 5 to both sides to get y by itself, and we get 1/2 x plus 4. The other way that you can write this equation is you graph these 2 points, find the slope by looking at the graph, and then find out where that graph will cross the y-axis, and then you'll be able to come up with that equation. We have 3 different kinds of scatter plots. We have one that has a positive correlation. Now this is really linear, but we could have points all over, but as long as they look like they're giving us a positive association, we call it positive. We have a negative correlation, and these points again don't have to be so tight together. They could be more spread out. And then the last one is a no correlation. We can't really tell what's going on with our data there, so we would say there's no correlation. A scatter plot is a graph that allows you to analyze 2 sets of data. Up until today, we have not used 2 sets. We have used just 1 set of data. Causation. This determines if one variable is caused by another variable, and we'll go through some examples here in a minute. Correlation, this is when data that follows the same pattern. We have 3 different kinds. We have positive, negative, or no correlation. And then this last part I just wanted to keep on there. A strong correlation does not imply causation. So here I have just a kind of a fun little picture here. We have this observer here, and she sees that, these people have umbrellas, so it's raining. So she gets her umbrella over here and says, hey, why is it not raining? Make it rain. So here we have an understanding that this umbrella does not cause it to rain. So there we have an example where the correlation does not equal a causation. So here's some other examples that we talked about. We have car accidents and the cost of insurance. The more car accidents you have, it causes your insurance to increase. The next one we have running speed and a heart rate. The more you exercise or the faster you run, it causes your heart rate to increase. And then the number of apples that you purchase causes your price to increase. So some examples where there might be correlation, but there is no causation. Age and number of MP3 downloads. So the older you are, there might be a correlation. The older you are, the less likely you are to have an MP3 download, but that does not, age does not cause you not to have the downloads. Distance of field trip and number of snacks eaten. Now, probably the longer your trip is, the more likely you are going to eat more snacks. But eating snacks is not caused by the distance of the field trip. And then speed and volume of a car stereo, we can see that speed is not caused by volume, or vice versa, volume is not caused by speed. So in example 1, it says the following table shows the percent of Americans with broadband connections at home in a recent year. We're going to create a scatter plot to describe the correlation, and then we're going to determine if there is causation. So when we do this in our calculators, you're going to go store age as L1 and the percent as L2. And remember to do that, you're going to press Stat and Enter. It will allow you to edit and put them in List 1 and List 2. Once you have them stored, you're going to go to second, y equals, remember that is a stat plot. And I would check to make sure that you only have one stat plot turned on. And then once that's determined, then you want to choose a scatter plot. And then zoom 9 once you choose that scatter plot. When you choose that scatter plot, notice that it says your X list at the bottom is choosing L1 to be the X list, and your Y list is choosing L2. Of course you can change those, but we're going to leave those as it is right now. So when we graph it in your calculator, we'll press zoom 9, and we get a graph that looks somewhat like this. So as we look at this graph, we can see that there is negative correlation. Okay, then the next question says, is there causation? So does your age cause the percentage of Americans with broadband connections? And we can say no. There is no causation. Between age and percent of Americans with broadband connections. Okay, your correlation coefficient. This is a statistical index of a linear relationship between two things. And so that's really fancy wording for it's a number that we get. And it's between -1 and 1. And we're going to learn some things about those numbers. If it's positive, then there's a positive relationship between the variables, and we should see something that is positive. We won't necessarily see that straight line, but we'll see our data values that are increasing. If it's negative, then there's a negative relationship, so our scatter plot will decrease in that way. If R is 0, then there is no correlation between the variables, and we get a scatter plot like this. We don't quite know what is going on with our values, and that would describe a no correlation. The closer R is to 1 or -1, the more linear the line is, and the more closely related the points are. And I probably should have worded that a little better, but what it means is if you get 1 or -1, those values will line up exactly so that it is linear if it's +1, or they'll line up exactly like this if it is -1. The closer that R is to 1 or -1, it becomes linear. Okay, so example 2 says, the table ranks the 10 tallest buildings in the world. Find the correlation coefficient. What does this tell you? So again, we're going to list our first one as L1, our second is L2. I want you to graph the scatter plot just to look at it, and then I will teach you how to find the correlation coefficient. So when we graph this, we can see our scatter plot will look something similar to this. So this tells us, first of all, that there is a negative correlation. And from here, I'm going to teach you how to find it. You have to make sure that there's what's called a diagnostics on, otherwise we aren't going to be able to find this. And the diagnostics on we find in the catalog by going second 0 and scrolling down until we see this diagnostics on. Then you'll press enter and then enter again, and it will say done. That means it's turned this diagnostics on. Once that is on, then we'll go to Stat, arrow to Calc, and choose 4. 4 says linear regression, and then you'll press enter, and it will give you a bunch of information. Here it tells us that R is -0.607. Now we could look at our graph and determine that it was negative. We knew that it wasn't strong negative, so we can see that here the closer that number gets to -1, the more linear our line becomes linear, and here we can see it's not quite linear. And so that tells us a little bit about the correlation. What does it tell us? That there is a negative correlation between rank and stories. Okay, the only unfortunate thing about this assignment is it's going to require a lot of calculators, so I gave my students a lot of time in class to work on this with their calculators. So you can go to Google and download a calculator, and it will work on your computer if you need to do so. So our assignment 7-4 scatter plots and correlation coefficients. Good luck.